I am coming to you today to go over the last part of 1.7. So in class on Monday, we talked about solving absolute value equations, and we didn't quite get through all of the details. So we are going to go ahead and wrap up the last few problems. So we did problem 1 and 2 from your notes page on Monday, and so I want to go ahead and do problems 3 and 4, and then one extra problem actually, and talk about that. So let's jump right in. So problem 3 says solve the equation, the absolute value of 6 minus 3k equals 21. Let's head over to Paint to do this. Oops. Okay, so we have, this is number 3 from your notes page. We have the absolute value of 6 minus 3k equals 21. So the first thing to remember, what we talked about on Monday, is how do we solve absolute value problems? Well, we kind of just have to do some thinking about what absolute value means. So whatever you're taking the absolute value of, whatever is inside the absolute value, is going to be evaluated as the absolute value and lead us to 21. So if you're thinking about this problem, what's inside the red brackets, 6 minus 3k, that either needs to have a result of positive 21 or have a result of negative 21 in order to get a solution of 21. So what I mean by that is once I evaluate 6 minus 3k, the inside number has to be either 21, right? Because the absolute value of 21 will give us 21. Or when I evaluate what's inside, another possible answer is negative 21, right? Because the absolute value of negative 21 is also 21. Let me switch my colors there so you can see, maybe. There we go. So the absolute value of negative 21 is also 21. So that tells us that 6 minus 3k has two possible solutions. So 6 minus 3k could be 21, or 6 minus 3k could be negative 21, because either of those two results will give us, once we take the absolute value, an answer of 21. Okay, so then it just, once we figured out how we can set up our equations, then it just comes down to solving for k so we can figure out what values make this equation true. Okay, so we'll start over here on the left-hand side. 6 minus 3k equals 21. I'm going to subtract 6 from both sides, and I will be left with negative 3k equals positive 15. 21 minus 6 is 15. Then I need to divide both sides by negative 3. And I get that k could be negative 5. That's a possible solution, right? All right, but that's not the only one. We also said, or it could be 6 minus 3k equals negative 21. I'm going to solve the same way. So I'm going to subtract 6 from both sides. So I will get negative 3k equals negative 27. Again, I want to divide both sides by negative 3 to get k by itself, and I end up with k equals positive 9. Okay, so if I do a super quick check and I plug in each of these to my original equation, you'll find that if you plug in negative 5, 6 minus 3 times negative 5, you'll get a positive 21, and that's a possible solution. If I plug in 9, 6 minus 3 times 9, I'm actually going to end up with negative 21, and that's okay because negative 21 and take the absolute value, and that's positive 21. Okay, so that is how we solve absolute value problems. We're going to talk about one other step that you might need to think about. So back to our notes here. So problem number 4 says, solve the equation, check for extraneous solutions. Okay, so we've got this extraneous solutions. We'll talk about what that means. Extraneous solutions aren't just unique to absolute value problems. It's going to be something that we have in other parts of Algebra 2. But basically what happens is sometimes when you use the tools that you have to solve a problem, sometimes the solution, the variable we've solved for, doesn't actually work when you plug it back in. So if you're asked to check for extraneous solutions, that means plug in, solve as you normally would, plug in the solutions that you come up with and see if they actually work within your equation. Okay, so one of the reasons we need to check for extraneous solutions, why this one looks different than the other problems we've done, is if you'll notice in this equation that we have an x on both sides of the equation. So we have a variable on both sides. So that's why we need to make sure that we check and make sure that all of our solutions are valid. So let's flip back over to here and see if we can solve this. So this is example number 4. We have the absolute value of 8x minus 1 equals 6x. Okay, so we are going to solve this the same way we just did the one before. 8x minus 1, which is in parentheses, right? That has to either equal a positive 6x or a negative 6x in order for this to be true. So it works the same way that we thought about numbers, right? As long as what's in the brackets here, this 8x minus 1, as long as that ends up either a positive or a negative value of 6x, once we take the absolute value, we're going to get positive 6x. So same process that we did before. 8x minus 1 either has to equal positive 6x or 8x minus 1 has to equal negative 6x. And again, that's because eventually down the road, if we take negative 6x and take the absolute value, which we are going to have to do, you get positive 6x. So that's why we have 2 solutions that we need to look out for. Okay, so now we're going to do some solving. And you have a couple options here. I'm going to start the left problem over here. You could send 6x to the left-hand side and the 1 to the right-hand side. You could send 8x to the other side. Either method will work. So let's just go ahead and subtract 8x from the left-hand side. And we will be left with negative 1 equals negative 2x. Okay, then we want to solve for x, divide out our negative 2. And we get that one possible solution is x equals 1/2, because negative 1 divided by negative 2 is going to give you positive 1/2, 1/2. Okay, so then our second problem, 8x minus 1 equals negative 6x. I'm going to just subtract 8x from both sides again. And I'm going to end up with negative 1 equals negative 14x. That's interesting, right? Divide both sides by negative 14 to get x by itself. And we end up with x equals 1/14. So our 2 solutions are x could be 1/2 and x can be 1/14. Now they've asked us to check for this extraneous solutions. So all that means is that you need to plug these 2 back in to make sure that they're both valid solutions. So this is our check over here. So we're going to check 1/2 first. So 8 times 1/2 minus 1, absolute value, does that equal 6 times 1/2? So let's see. Does it work out? Well, 8, we're going to do inside the absolute value first. So 8 times 1/2 is 4. 4 minus 1. And then over here we have 6 times 1/2, which is just 3. 4 minus 1 is 3. So once we get there, we're pretty sure absolute value of 3 equals 3. That works out for us. So this is a valid solution. So one possible solution is x equals 1/2. We also have to check 1/14. So we're going to really test our fraction skills out, right? We're going to do 8 times 1/14 minus 1, absolute value. Does that equal 6 times 1/14? More fun with fractions, right? 8 times 1/14 is 8/14. And since I know I have to subtract a fraction, I'm going to go ahead and change 1 into 14 over 14. And 6 times 1/14 is 6/14. So 8 minus 14 is going to give me negative 6/14, absolute value. Does that equal 6/14? And it does, right? When I take the absolute value of a negative number, it's just the positive. So that works out. So in this case, they had us check for extraneous solutions, but it ended up that both solutions were valid. That's not always the case. There are some problems that when you plug in the extra values, or when you plug in both values that you've solved for, that one of the two variables that you found is not going to be valid when you actually plug it back in. But in this case, it works out for us. Okay, so that is 1.7. I am actually going to save the third problem I was going to do. It's not on your notes page, but I will save that for our call on Friday to do in person. And if you have any questions from then until now, send me an email. And if not, we will talk on Friday. Thanks for listening. Have a good day. Bye.